3, I think by far the most reasonable of them. So maybe we'll get one that's a little more like this. But if we get a harder one like the last two, we're just going to try to get what we can out of it. So I got a picture of g, and it says it's the derivative of f. So you can also call this picture f prime. And it says a bunch of stuff about it. You can read that. It says find all the coordinates on the open interval for which f has a local minimum. So we're not trying to find an absolute max because this is an open interval, so just a local minimum. So any place where this graph goes from negative to positive. So I would say f has a local min at x equals 6 because f prime or g goes from negative to positive there. If you're writing an explanation, it should always be one sentence, put a period on it. Next is find the coordinates of the x coordinates of the points of inflection from 0 to 10. So point of inflection is where the second derivative changes sign. Second derivative is the slope of this picture. So there'll be one at 4 and one at 8. So we would say we have points of inflection at x equals 4 and x equals 8. I'm not going to write it, but I would say because these are the places where f double prime or g prime changes signs. Next page says, given that f of 2 equals 5, write an expression for the interval. So on the interval 0 to 11 that involves an integral for f of x, use this expression to determine f of 0 and f of 10. Okay, so if I think about how I would say find f of 10, if I knew this area right here, and I knew this area, so the value I know is f of 2 equals 5. So I'd start here and I'd subtract this area, I'd add this area, I'd add this area. And they tell me that these areas are this area is 4, this area is 3, this area is 2. And it doesn't tell me that last area, but I'm not going to need it. So the way I would write this is I would say f of x is equal to 5, that's the starting value, plus the integral from 2 to x, my starting point to where I want to go, of the function f prime, which is in this case g, and we can't use an x in here, so we'll call it g of t dt. Okay, again, figure out how you would calculate a value and then figure out how you'd use that more generally. So then they want me to find f of 0. So that'd be 5 plus the integral from 2 to 0 of g of t dt. I don't like doing this on a picture, so I'll flip it and I have to change the sign. So we'll go from 0 to 2, but the opposite of it. So the area from 0 to 2 is 4, but since we're subtracting it, we'll get 5 minus 4, which equals 1. Okay, and then if we're going to do f of 10, go over here. F of 10 is going to be 5 plus the integral from 2 to 10 of g of t dt. Okay, so we get 5 plus from 2 to 10, so we get minus 3, which gets me down to 2 plus 2 is 4. So a total, we get a negative 1 out of this, so we get an answer of 4. Sorry, struggling with my pencil. And then D says, evaluate this limit. So first thing I'm going to attempt to do is to plug an 8 in. If I plug an 8 in, I get g of 8 minus 1 over 63 minus 64 plus e to the 0. So g of 8, if I go look at the picture, g of 8 is equal to 1. So I end up getting 0 over 0. You can pretty much guarantee if you're asked to evaluate a limit on this test, it will be a L'Hopital's rule one. So I'm going to use L'Hopital's rule, which means I take the derivative of the top, which is g prime of x, over the derivative of the bottom, which would be negative 2x, plus e to the x minus 8. And I'll attempt to plug in 8 in again. So I'll get g prime of 8, which if I look up here, g prime of 8 had to be equal to 1. G prime of 8, I gotta go look here. So g prime of 8's at the top there, so that's a 0. And then on the bottom, I get negative 16 plus e to the 0, which would be negative 16. Oh, sorry, that'd be negative 15, that's a 1. So negative 15, so I get 0 over negative 15, which is just 0. Sorry about that. Last, it says, here's this function h of x. Find the slope of the tangent line when x equals 4. So we're first just going to find h prime of x. So we get 2 times all of this times the derivative of the inside, which would be g prime of x plus 3. So I'm going to go ahead and put a 4 in. That's all they want is the slope. All right, so we got 2 times g of 4, so this is a picture of g. G of 4 is negative 1.5, so we get negative 1.5 plus 12. That'd be 10.5, which would be 21. G prime of 4 is the slope here. The slope there is 0. So this becomes a 3, which means we get 63. Okay, there's all of number 1. Be back for number 2 here in a sec.